Computer Science. Welcome all of you to this wonderful session on malware analysis and classification. Today is our speaker, resource person is our Dr. Sindil Kumar. I welcome you, sir.
Yes, sir. Good morning. Thank you.
Morning. So let me introduce, sir. Dr. T. Sindil Kumar currently serves as Associate Professor at the Department of Computer Science and Engineering at Amrita School of Engineering, Amrita Vishwa Vidyapeetham, Coimbatore. His research interests include video analytics, big data analytics, intrusion detection systems. He completed his BTech in Computer Science and Engineering from Setu Institute of Technology, Madurai. He then completed his MTech in Distributed Computing Systems from Pondicherry Engineering College, Pondicherry. He completed his PhD in Information and Communication Engineering from Anna University, Chennai. He has received appreciation in Indian Express for agent-based programming for banking domain. He has published papers in 9 national conferences, 12 international conferences, 14 national journals, and 10 edited book volumes. He has 22 Scopus publications. He has published a book on C++. He is a reviewer for Elsevier Computers and Electrical Engineering Journal. He is a guiding scholar with Amrita Vishwa Vidyapeetham in the area of video analytics, intrusion detection system. He teaches courses in video processing, video analytics, machine learning for big data. He has involved himself in coding in the competency areas of programming like MATLAB, NS2, uh, JIST, .NET Android, Hadoop, Spark, OpenCV with Qt, Amrita Vishwa Vidyapeetham, Coimbatore since 2001. He has membership in professional bodies like CSI, IET. I wholeheartedly welcome you, sir, for this session. Now I request Dr. Sendil Kumar, sir, to continue the session. So it's to you, sir, now.
Yeah. So good morning. Am I audible, sir?
Yes, sir. Yes, sir.
Yeah. So thank you so much for the introduction, and thanks to Manju ma'am, yourself, and the team of Gopalan College of Engineering and Management for accepting myself to be a session speaker. And my sincere thanks to your principal, Dr. Sengotin sir, for hosting me on the session also and giving the needful support. So today's session, as we have been trying to communicate to all the participants, today's session will be having a bit of theory and then we'll spend some time on programming, right? Today's session, I'll be completing on how to do malware analysis with machine learning. Okay, that's a plan for today's session. So my next session will talk to you on malware analysis and deep learning. Okay, so that's how I planned my sessions. So please listen wherever we are not understanding something. Please interact and make sure that your programming platform is also ready, so that once we are trying to do programming today and the following session, we will do a good job, right? Okay, let's come to the first thing for everybody. And the first question somebody would ask is like, okay, let me understand what is malware and why every one of us is talking about malware, and how do you do your state of art of research or projects with respect to malware, right? Okay. Um, See, to all the people, it is something like malware, as the name indicates, or it looks very different. People understand that it means a program which is not okay, which is not supposed to run on your system. So you can call it as a malicious computer executable, right? And malware, as the name indicates, it doesn't run with the user's consent. That means we don't know that a program is running, but a program would run, but do an activity on our behalf. So that's the second thing. So malwares, again, it's not only virus or worm, right? Okay, it need not be confused with virus or worm also all the time, right? Now, why is this malware getting increased nowadays? Is all of us should understand that we have moved from wired connection to wireless connections, right? Okay, if we are within an office and we are all connected on a computer network, there is not a possibility to for us to say that malwares will come, right? Okay. But today it's not like that. The chance of malware is increasing because we are connected on the wireless network. So what are the devices we connect? We connect laptops, we connect mobiles, we connect iPads. So any wireless node that is going to connect is going to send and receive data on the open network. Open network means it's going to send and receive data on the wireless network. So there is a lot of third party to access your data, and there is a growing chance that your network is being attacked. So this is the only reason I always keep to people saying that why are we having malwares is only this reason, right? The second reason is, see, all of us today are having possibility to install some programs. For example, you see something on a mail saying that, see, this is a very good software you install, please make use of it. Somebody would try to click and install. That can also become a malware at the end, right? Each one of us would have experienced such a situation. Then the next thing is like, what are the top 10 malwares? This is presented in the state of art. As you can see here, the first malware is packet.malware.anti.ad is the first malware. And this I'm talking about from the ranking aspect, right? There are other malwares like Trojans is there. There are malwares related to Windows 32 is there. There are malwares related to Packer is there. Okay. And this list is keeping on increasing. So according to 86% of the reported attacks is basically spywares, right? Okay. So why we are talking about this is to all of us to conclude spyware again is a type of malware. So when somebody says my system is attacked, you would say that I got a virus, I got a worm. Then you would say that I have a spyware, I have an adware. Then people say I got bots, trojans, keyloggers. Okay. So all these are basically types of malware. And in the state of art, people say that most of the attacks are related to spyware. Okay. So in fact, it goes to around 86%, right? Okay. Now, let's come to the next thing here about virus and worms. See, all of us know that worms are the oldest one when you talk about malicious programs. As far as virus is concerned, it requires a system to do an activity. For example, you need to work on a program. That program, if it is having a virus, that will start doing a malicious activity on your system, right? So that's why we say that virus requires an user interaction. But both worms and virus as such can start spreading through emails also. You get a spam mail and you try to click it. If it carries a virus or a worm, there's a lot of possibility that your system is getting attacked with a virus or worm, right? Now, next category of malware is about spywares and adware. Spywares has become very important in analysis. Reason is we are all using internet. Whenever we are using internet, there is possibility for spywares to come, right? As far as spywares is concerned, doesn't spread like virus, but instead what it does is it runs more like a peer-to-peer programs. That means once a spyware is attacking your system, then there is a possibility that you would say that your program is not monitored by your system, but instead your program is monitored by some end system. End system means somebody has got control on your computer, and that actually can do some operations. For example, an example of a spyware would be like, let's take your system is attacked by spyware. Whenever you open your browser, no, you will find that there's a lot of pop-ups coming up, right? That pop-ups will be actually coming up without you trying to work with the spyware. Right? So that's an example of spyware. Okay, the next as such is about bots and trojans. Bots as such, what they will do is they'll infect multiple systems. For example, if you say that a bot has landed in your computer, and if your computer is connected to a network, what the bot will do is bot will start spreading across all your systems in the network. That means if you are one computer out of 100 systems, there is all possibility that your bot will affect all the 100 systems, right? So bot as such differs from Trojan. What Trojan will do is Trojan will as such will try to install actually a software. So that software can be either called as an adware. What is adware is what we saw from the previous category. It's also a malware, right? So a Trojan as such can install an adware. Instead, what it can start doing also is it can start doing all recording of your key operations. For example, let's take you are trying to access a bank account. You're trying to send a mail. You'll try to type something on your system, right? Your data is carried by your software, but your data as such will recorded by your adware or keyloggers, right? So keyloggers are very dangerous. So there is a lot of possibility that your system accounts can be hacked. There's a lot of possibility that your bank accounts can be hacked. So that's about keyloggers. Now, why we are uh, having all these problems, right? Okay, it is actually because we are all forced to use operating systems. Nevertheless, I'm not trying to put this operating system is good, that operating system is good, like that. But let's take any discussions, right? You are looking at an operating system, for example, let's take it's Windows, right? And there is possibility that you are trying to install a Windows operating system, then there is a third party that could be installed, right? When you are trying to install something from the internet. And second thing is, let's take you're trying to use an external device. Nowadays, you don't have a floppy disk, but let's go back from the past. If you're trying to use a floppy disk or a CD drive or a USB drive, there's a lot of possibility that each of can carry a code which can be understood as a malware, right? Okay. The next possibility would be is like once a malware is landing in your system, right? There is a situation that there is something with respect to privileges of the users. Most sometimes what people will do is they will try to say that everybody has an admin privilege in your computer. For example, if there are 3 users in your network, you would say that there are 3 users, but all the 3 users are admin users. So if they are admin users, what happens is there is a lot of possibility that the admin user can try to access important data in your computer, right? So this is the next problem, that is overprivileged users. And next is allowing a program to run as a overprivileged user, that it becomes something called as overprivileged code. The next, which everyone knows, no, we will talk about virus. You know everything about virus, what a virus does, right? So virus as such is basically a replication model, right? Okay. So once a virus is infecting your computer, it is attached to a program. Let's take its Word. Once you install Word and you're trying to open Word application, whenever you open the Word and if it has a virus, it will start spreading something on your system. So that's why we say that virus requires a program to run all the time. Lifetime of a virus, as everybody knows, it is more dependent on the triggering part. Your system will not spread the virus until you run the program which is infected by virus. So if you have a program and the program is infected by virus, right, and whenever you click the program, only then the virus will become active. So what I say to people is the most important phase for every virus is basically the triggering phase, right? So this is how the structure of a virus program generally looks like. So as such, if you can see here, you can try to get a quick idea here. So subroutine, all of us know it's as a function, right? So we have one function called as executable. So whenever the file is getting executed, right? So automatically it will do some damage. The damage will come under this function, right? And it'll have something for trigger, right? Okay. So in the main part, what is said is like whenever the program is getting executed, the trigger will be invoked. The trigger as such will call damage and it will do something on your system, right? So this is a general virus structure. So these are different types of virus: parasitic, memory, then boot, then stealth virus, polymorphic virus, and next is metamorphic virus. Usually what people experience is actually the stealth virus, right? Whenever you're trying to put your pen drive, right, and you're trying to access some data, automatically you would say that, yes, I had a file in a pen drive. Now my file is copied to my system, because of which the file is having a virus. My system is also infected by virus. So most common virus that you will actually see is something called a stealth virus. The next is about email virus, which every one of us know. You would actually get a mail and you try to click the mail, automatically your system gets infected, right? Okay. So email virus is most challenging. Nowadays, we say that spam folder in all your mail account will take care of the virus, right? If your system is getting a mail and it carries a virus, it'll go to the spam. But people who design viruses is also very intelligent. I think each one of you know, right? Okay. Whenever you get a mail, sometimes it will be in the spam as a virus. Sometimes you will get as a normal mail itself. You'll try to click the normal mail, then it will try to say, should I install this program? You try to say yes, then automatically it installs. That means your system is infected by virus, right? The next category of malware is something called as grayware, right? What is grayware is a program installs on your system, and tries to report something about your activities back to the owner, right? Suppose I want to monitor what you're doing in your computer. I can install a Grayware from my remote, and the Grayware, what it will be running as a daemon program. DAEMON. It will run as a daemon program. So the Grayware as such will try to take some data relevant to whatever you're doing in your computer. So that's an example of Grayware. Grayware is very hard to monitor, right? And in fact, you will be very surprised that your system is already attacked at one point of time. Right. The next category is Trojan horse. Trojan horse is other way of handling a way of looking at a virus itself, right? Okay, so Trojan horse also does something as like virus, but only thing is Trojan horse differs in the way because it doesn't propagate by self-replication. Virus is not like that. Whenever a virus is spreading, no, it replicates itself in your computer, right? Trojan horse is not like that. It doesn't replicate itself by its computer on your computer, right? Then next is about worms. As far as worms is concerned, what it will do is it will do a replication, right? And it will replicate from one computer to another computer, right? If you're connected on a network, you can see that once your system gets a worm, then automatically it will try to spread itself from this computer to the next and then to next. Okay. So worms will get spreaded from one system to another. So how does it replicate? As we see, I try to connect one network, right? And that network is having a worm, then that case automatically my system is attacked by worm, right? And the next possibility is like you are trying to remotely execute your program on that system. That means you have a program, but your program is not running on your computer. You want to run that program on somebody's computer. And that computer carries a worm, then automatically your system gets attacked by worm. The third case is by email. You get a mail and click and download, automatically your system also gets a worm, right? So all this leads to something called as an attack, right? Why every one of us is worried about all this malware is we are worried about this keyword called as attack, right? So attack as such, what you would say is my system is attacked. Other way, what the IT industry will say is like your system is compromised, right? Compromise means you are not the owner of your system. Somebody is becoming the owner of this. Or let's take your network is compromised. It's become very dangerous, right? Let's take you run a bank, right? And you have a banking network. I come to you and say that your network is compromised. Your bank network is compromised. Be very shocked because all your bank accounts is not with you. It is a bank accounts with somebody who is a third party owner of the network. And the owner of the network is hosted a malware because of which the owner is able to get all the data about your banking network. So that leads to something called as network-based attacks. So system-level attack, okay, we can very well agree that it is possible. I'll install an antivirus or I'll install an anti-malware and so on. But a network attack is very hard to handle, right? And this leads to something called as denial of service. So as the keyword says, what is denial of service? You are not able to do your routine activity in your system and your system is compromised. That means your system is no more part of your network, right? So there it's called as a denial of service. When you say distributed denial of service, you are not doing the attack only on one network. You are doing network attacks on sub-networks. So in overall, you will say that all the entire network is not under the control of the owner, right? So the entire network is compromised. So there we talk about distributed denial of service, right? As I said when you talk about networks, then there is possibility of having more servers. There's possibility of having networks, right? So finally, you will say that in distributed denial of service, it is actually understandable as it is network with subnetworks all being attacked, right? So when you talk about an attack description, okay, how do you describe an attack description? You can actually describe your attack description based on two categories. One is your resource-based attack, and the next is data transmission-based, right? Resource-based attack in the sense, what is the attacker trying to steal from your system? Maybe the attacker might try to steal your bank accounts. Your attacker might try to steal your user ID password, okay? Then other possibilities like what sort of the data transmission the attacker is trying to do. For example, the attacker is trying to send the data of yourself to the pool of servers, right? How the attacker is trying to handle it is very challenging. So when you come to the internal resource attack, now here we are talking about bit of networks. When you talk about networks, each one of you know that our underlying transmission model is TCP/IP model, right? So we are trying to use this SYN packet, right? Whenever you are trying to communicate over TCP/IP, you would say that I'm setting the SYN bit to be 1. SYN bit means synchronized bit to be 1, right? So you want to send a data to somebody, you would actually say that I'm setting SYN bit to 1, right? The receiver also sets the SYN bit to 1, right? That means we are synchronized. Now we can start sending the data. For every data being sent, right, there'll be a next bit that will be handled, which is called as ACK, right? Once a receiver gets a data, that's a packet, then the receiver will set the acknowledgement packet bit to be 1. Otherwise, the acknowledgement bit packet to be is set to be 0, right? Okay. Now, whenever you send a data from your system to some other system, your conclusion finally that your network is not attacked is when you have your proper SYN bit and proper ACK bit set and handled. But what happens if the receiver is not getting the data, but the attacker is getting your data? So once the attacker is trying to get the data, now there is a difference. Let's take I want to send a data to a node called as A that carries a valid IP address. But the data is now not going to A, but instead the data is going to node B, which carries an IP address, right? Now the challenge here is how do you identify that B is not A? A is an authentic node, right? Whereas B is an attacker. So there what happens is B as such will try to give a dummy IP address, which will try to indicate saying that it resembles as A and the sender will not be able to find, right? Okay. So this is the second problem here. So we are not able to have the nodes being identified at all. Now the scenario, as you can see here, this is attack machine, okay, and this is all servers, right? This is all servers in the network, right? Now what we try to do is once the data is sent from your attack machine through the servers, it starts sending synchronized packets. Now the SYN packets is now in synchronization with your web server, right? And it is supposed to send a valid SYN/ACK packet back to the sender, right? But assume that your network is attacked. That means your system is also attacked as part of the network. Then there it falls into something called as distributed SYN flood attacks. And second, the point that we talked about is data transmission resource, right? Okay. So what is this data transmission resources? The attack as such, what it will do is it will try to indicate saying that the attacker is trying to send the ICMP echo packets, right? And this ICMP echo packets will be sent to not one computer, okay, but it will be sending to multiple computers, right? So when it is sent to multiple computers, what happens is you want to send the data to one receiver, but now the data is not going to one receiver, but the data is going to n receivers. Once the data has to go through n receivers, all of you will accept in the theory saying that the data has to be transmitted through some networking device. It could be a router. So now what happens is the router originally is supposed to handle one request going to the receiver, but now it's getting n requests going to the receiver. So the router's bandwidth might not support. In such a situation, what happens is the router is getting flooded and the router is not able to respond, right? That's the next way of looking at this attack. That is, consumption of data transmission resource will be increased. What is the data transmission resource? That's your router, right? So this is what happens in a distributed ICMP attack, as I told you. The data is going through the servers, right? But what happens is the request is supposed to go to only one target, right? But the router is supposed to get only one request, but the router will get n request, right? So how it is n request? The attacker will try to create multiple instances of the same request going from the sender. So it's not one request with this n request, so automatically the router is flooded. Okay, so this is an example of distributed ICMP attack. The third category, which we have been saying, which is your direct DDoS attack, right? What is direct DDoS attack is like the attacker as such can actually implant zombie software, right? The zombies as such, it will actually prevent the owner from knowing that there is an attack in the network. I'll again repeat, zombie will prevent the owner from knowing then that there is an attack in the network, right? Now let's talk about here. When you talk about this here, this is an attacker and this is a victim, right? Victim means the nodes which is getting attacked, right? Now the attacker as such will create instance of zombies. Zombie is a software. Again, I'm saying this, zombie is a software. So the zombie will be calling itself under two hierarchies. One is a master and next is at the slave level. Master means something which you can call it as a server, and slave as such you can assume it to be client. So master zombies and slave zombies will be created and they will work with the attacker and they will bring down the activity of the node. So the node now is not a regular node. The node is now attacked. So you call the node as a victim here, right? This is what is called as direct DDoS attack, right? The next category is called as reflector DDoS attack. What is reflector DDoS attack is the slaves as such will send packets to reflectors, right? Okay. So when you talk about the reflectors, what the reflectors is supposed to do is will respond with packets directly to the target mission, right? So the reflector DDoS will involve more computers. So naturally, it's very hard to detect the type of attack. Now let's see the reflector DDoS attack. Same, you have an attacker, you have victim node, right? You have master nodes, we have got slave nodes. They are having zombie to simulate that attack. But see the number of interconnections. Can you see here? The number of interconnections will be high. All zombie will be connected to all other zombie in the network. Now the hierarchy change that you can see here also will vary. In this case, it is level 1 hierarchy for the. But when you're going for the reflector DDoS attack, there will be reflector nodes which will be understood. So this reflectors will bring a 2-level hierarchy. And one more is the interconnection will exist from all zombie to every other zombie in the network. This is an example of reflector DDoS attack, right? Now, usually people will ask a question, fine, I have got a doubt, my network is attacked. How do you find the victims? One possibility is like randomly you have to check your network, right? The next possibility is people do know. You actually run your antivirus software or the anti-malware and check whether some node is attacked. The next possibility is like you have to go from the topology part, right? Last category would be is like check at your local subnetwork. If your subnetwork is not attacked, then you can conclude that your original network is also not attacked. This is general suggestion from the people. Now, if you are trying to write something on the malware detection, right? So what you are trying to see is you are trying to see whether there is a suspicious behavior in the network, right? So to do it, you need to do two aspects. One is you need to have some knowledge of what is malicious behavior, and then you need to write a program that will inspect. Okay, that's what we are going to do or simulate it for today's session, right? We are going to have a program which will take a malware data set and then it will try to analyze and say that it has got a malware or not, right? So malware detection techniques are categorized like this. You can either go for signature based or anomaly based. Anomaly based is under having a category called a specification based. Each one of them, signature, anomaly, specification, has subcategory as static, dynamic, or hybrid, right? So anomaly based technique, as we told you, the first category that you saw, we will be able to take the normal behavior of a program and check whether the malicious program is running or not. In signature based, what we do is we try to have the characteristics. What we are going to discuss today is on signature based. So we'll take the features and with the features, we'll try to conclude and say whether it's a malware or not, right? Then third category, a subcategory that we have seen under each of this is static analysis, dynamic analysis, right? If you have a doubt about what I'm discussing, I'm talking about this category, static, dynamic. Third category is hybrid, which is combination of static and dynamic. Okay. So when you talk about static analysis, what it does is like it will actually do a static analysis of the program, right? That means before the program executes, the static analysis will run. Dynamic is otherwise opposite to static analysis. Once a program is running, during the program execution, it will try to understand the behavior of the program and then it will try to conclude saying that there is a malware or not, right? Okay. Then next one, which we will take up is understanding on the features, right? Now, the next question that we have in discussion is, okay, I want to understand malwares. Can we go into malware analysis and start understanding the malwares? So there are a lot of data sets for understanding malwares, right? Usually I put this data set as a common data set nowadays, which is bot IoT data set. Okay, bot IoT data set. This data set as such will have most of the characteristics of a real-time traffic. Today, when you talk about network, each one of you will agree that your network is not running with only computers. Your network is running with devices, which can be mobiles, which can be embedded onboard devices like that. So this data set has got most of the characteristics, right? This data set has got most of the characteristic. And now the next question would be is like, given a data set of malware, doing something which is called as a classification or a prediction, right? Okay. So next question people will say is like, what are the class that you're interested in analyzing? So we will look at two class of data. One class of data would be calling itself as normal. The other class of data will call itself as a botnet, right? So this IoT botnet data set will actually simulate this two type of traffic. One is called as a normal traffic and next one is called as a botnet traffic, right? Okay. Now, the next information people have to understand is the description of the data set. Whenever you do your project or your research with any data set, next question would be is a description of the data set. This data set extension is a PCAP file. This data set extension is a PCAP file. Now at this point, people might get a doubt, what is this PCAP, right? Okay. PCAP as such is a library, right? Okay, which actually can capture your packets. If you go to internet and type PCAP library, right, you will actually get description about PCAP library. Can you get it, right? I'm talking to you in the way in which I have learned. Okay, so take it as a student level description also. So PCAP is a library through which you will be able to capture the packets. So whenever you simulate a network traffic, you can save your network traffic using PCAP extension. So now comes the question, can you give me a simulator which will actually generate network traffic? So there, the common simulator which I suggest to people is Wireshark. The common simulator which I suggest to people is Wireshark. So once you are installing Wireshark and keeping it in your system, then automatically you can capture your network traffic, right? Like for example, your computer is now connected on the network, right? Because you are listening to my session and you're doing some activity on your system also. All packets that you are trying to communicate to your system can be actually saved by using the simulator. So suggestion is you can install Wireshark simulator, you can run it, you will be able to capture the packets, right? Whatever is your packets in your system, right? The other alternate people actually say for packet capturing is your Cisco packet tracer, right? I think most of the colleges now has packet tracers. The other possibility is you can actually use a Cisco packet tracer. Cisco packet tracer also allows you to save your data as a PCAP file. Okay. Now, I think this keyword should be meaningful for everybody. What is a PCAP file? Anything that is captured through a simulator. Now, this data set as such is 69.3 GB size. It has got around 72,000 records, right? 72 lakhs records, right? You can assume it like that. So the data set again has got different type of attacks. You can see, as we saw in the theory, distributed denial of service. Then we have DOS attack, attacks related to OS, then attacks related to service scan, key logging, data exfiltration attacks, right? Okay. And this as such is actually further classified also, right? What is this further classified would be is like if you look at your network data, right? If you look at your network data and your network data is like this, where you say F1, okay, F2, F3, F4, right? Now, each one of you would ask yourself, okay, what is this F1, F2, F3, F4? You would say that these are all called as features. So example, somebody would say this is my IP address, okay. Then somebody would say this is my network length, fine. This would be called as your packet size, right? This would be called as your protocol, like this. So meaningfully, each network packet log will have a set of features like this. Now the challenge is, given these features, we need to find out what is a class, right? Now this class is what we have been saying here as something as DDoS, DOS, OS, service scan, key logging, and next is data exfiltration, right? Okay. So the data set that you categorize can actually be understood as the type of attack that you try to find, right? The attack can be classified as based on your problem. Here, what we talk about is a BOT iOS data set. Now, let's come back to our data set quickly, right? If you have data like this, we are interested in classifying the data, right? Okay. Now, when we want to classify the data, then now the question is like, do you have any sort of a benchmark data? That means, do you have a data set which is already having a class label? Now, you don't have any class label for this data set. Okay, let's take, for example, I'm just giving a random data. Please listen. I'm giving a random data set here. So let's give some random data. Okay. So now I got 4 records. Now each one of them has their own features, right? So this is 10. This I'm calling it as 11. This I'm calling it as 12. Now the question is, if I have these features, right, and I have some values. Let's take, I say 12, 11. I have 11. This is 10. This is packet size value that I'm providing randomly. Okay, right? You can use your own protocols, TCP, ICMP, right? So let's take IP, ICMP, all right? Now, if you ask yourself, what is your data set? You would actually say, I have 4 features on my data set. The feature names are IP address, network length, packet size, and next is protocol. Then the next question I would ask you is like, what is a class? I don't know the class because there is no class label for it. Here comes the question of asking whether there's a ground truth to the data set. Most of the logs will have ground truth. If they don't have a ground truth, then you have to use some algorithm from unsupervised model. If you don't have a ground truth, you will have to use some algorithms from unsupervised model. Example would be a k-means algorithm. If you run through a k-means, this actually will start saying this falls into some class. Let's take, I say 0, I call it as 1, this can be 1 and this can be 0. So this sort of classification is called as a binary classification, right? It's either 0 or 1, right? But there are possibilities that the class labels can be 0, 1, 2. There what happens is it becomes a multi-class problem because the class labels are 0, 1, and 2. Now the question, if you are asking what is algorithm we have used a k-means algorithm here. This data set that you have taken here is having 4 records, right? So you can actually go and start calling this data set as a training data, right? Because this data set is fresh data, right? This is how you should also create models, right? I'm showing you in this ways that things can start from your side also. So this called as your training data. So with your training data, you got a class label. So the algorithm that you have used is from unsupervised category, which is your k-means. Now comes the next question of asking yourself, like, what can be the test data? So test data means I'm getting a new traffic, right? My packet is recorded. So what is your packet? Okay, my packet is this. My length is 10. So my packet size is like this. Then my protocol that I'm using is IP protocol. Then people will ask you a question. Okay, all this is fine. What is a class that you're finding, right? So this process is what is called as prediction in machine learning, right? This process is called as prediction here. Already you have given a class label for all the records, right? This process is called as classification, right? So the challenge here is like to develop a model which will actually take a malware signature like this, right, as an example, and then say what is a class label to it can fall. If you can find it, there you are trying to use something from supervised learning. So example of a supervised learning algorithm will be KNN, K nearest neighbor. Example of a supervised learning algorithm would be KNN. So the first thing that you can all try would be is like take a malware analysis data and try using a k-means, right? And fix a class label. Once you fix a class label, you can give a test data, right? You can try with KNN, that's your K nearest neighbor, which is a supervised model, and find out the class it can fall. So here the class will be either 0 or it will be 1, 2. But sometimes what happens is if you take your data, which is your test data, to classes which is 0, 1 or 2. There what happens is the data set calls itself as an outlier. I'll again repeat, you get a test data. The test data should fall into any one of the classes that you have learned under the training. It should be either 0 or it should be 1 or it should be 2. But assume that it is not falling any of it, you call itself as outliers. So there people actually suggest to way approaches to handle the outliers. The approaches would be either data augmentation, or they would suggest that you can go for data sampling, right? Okay. Or people will suggest that you can go for boosting. So what is this boosting is to use boosting classifiers, right? So what we will also do today is like we will try one from general and we will try one for boosting classifiers. Example is AdaBoost classifier. Right. If you go to the internet, you will find something called as AdaBoost classifier. So one possibility of handling an outlier is you can actually use boosting classifiers. So if you use any one of these techniques, augmentation or sampling or boosting, your data, that's your test data, will be identified with some class. Right. Now what you have done is prediction is over. So the process of training data, if you don't have a class label, use some algorithm from unsupervised. Process of testing, you have to predict the data that with a corresponding label. If it is not possible as outliers, there use any one of the techniques, whether it is augmentation, sampling, boosting, and then find the class label it can fall into. Now what you have completed is something called as prediction here, right? Now the next question somebody would ask is, okay, all this is fine. All this is fine. How do you say that your algorithm is correct? So what is the algorithm that we are using here? We are using k-means with k-n. How do you say your algorithm is correct, right? So there what people talk about is performance metrics, right? There people talk about performance metrics. So there are many metrics for performance evaluation. As I've been saying, usually we can use precision, we can use recall, we can use accuracy, right? Like this. Now let's talk about what an accuracy can do, right? This will get you a quite good thought here. Now, all this mostly depends only on the testing data. Your testing data given is identified as 0, right? So what I do here is I'm just going and giving some other samples. Now please see here, I'm trying to give some more data. Okay, so now 5 records, 6 records, 7 records, right? Okay, now all these are your test data. Now all these are your test data, right? Okay, now let's take our class labels as 0, 1, 1, 0, and this is identified as 1. This is concluded by using KNN, right? Or using some approach for outlier handling, you have found the class label to be like this. Now, what will accuracy ask is, in case you have done the same thing with k-means, hope you are all people are able to get, right? If you're given this data and you have tried with k-means, so what would have been your class label that you got? So let's take my class label is like this. Okay, so my class label is like this, right? Now, if I ask a question, how much is your prediction correct? People will say that I compare it with k-means. If you can see here, the fourth one is incorrect, right? And next, fifth one is incorrect, right? And next, sixth one is incorrect, right? So out of totally 7 predictions, 3 predictions are incorrect, right? So your accuracy will be given as 4 by 7. Your accuracy will be given as 4 by 7. I think people can understand here. Totally, I have made 7 predictions, but out of which, 3 predictions are incorrect with KNN. So the accuracy is given as 4 by 7, which is something like 0.57. Now your state of art research or your problem will demand how do you improve your accuracy. That is where people say that I'm not using only distance based approach, something from kernel based approach. So example would be an SVM here. So with the SVM, what is your accuracy? You can try to go and check. In case your accuracy with the SVM, right, is something like 0.75, right, then you can conclude that using a support vector machine with k-means in the training part has brought my model to a higher level of accuracy. This is how you should look at performance evaluation of malware analysis, right? You can try an algorithm with supervised model, check the performance in terms of the metrics. If the performance is not good, try with some other algorithm. Here, what I'm suggesting is KNN is a distance based. SVM is basically a kernel based. With the SVM, I'm getting 75%. That means my accuracy is improved. Okay, right? So this is how you can actually take a data and walk through and see how analysis can be done. So if you come down to this, what we are trying to discuss, our discussion is more about how data can be classified. Okay, that's our discussion. So data classification can be done using algorithms. Here we have shown you an example of going through a IoT botnet data set, right? Okay. If you look at this, it will talk about an architecture diagram. So this is more similar to what we have been talking about, right? Our worry is about using the data set. So this dataset will be available under this link, UNSW dataset. If you want, you can actually download the dataset from here. Right? This will have the PCAP file, whatever is the internal files that they have created as part of the network attack also will be there. If you want, you can make use of this. Right? Any questions from the participants? Participants, any questions? Please put in the chat box. Now the theory session is done. We are now going to the programming session. Any questions from the participants? Ma'am, am I audible, ma'am?
Yes, sir.
Yeah, fine. Any questions from the participants? Please put in the chat box if there are any questions. How to extract time series data? Time series data, you are talking about malware, ma'am? Kirtana, ma'am, are you talking about malware-based time series analysis data? Yes, okay. I'll show you a link. One second. Malware. One second. Malware time series data. Yeah. Okay. I'll show you one link which will take you through understanding on malware-based process. So this link will get you an understanding on time series based data analysis for any data, right? Okay. Now, if you ask me a question, how do you provide it for your problem? Then only answer is like all this data doesn't have any temporal component. Now, what you can do is you can go here, right? And you can give it time. So this time can start going from minutes, for example, 9:1, 9:2, 9:3. Okay, this also can be 9:3 and so on. Now you can start associating your data based on time. Let's take within a minute, right? How many packets have gone? That actually you can build it as a time series model. And there you can conclude that your network has got more attacks on a specific time period, right? That's first point for you. And second point is when you start doing something with time series, naturally you'll be using algorithms like moving average, algorithms to understand the trend of your malware attacks, right? Because you are analyzing over a time, right? Third point is when you're trying to go for time series based model predictions, it's always better to go for stochastic approach or partially stochastic approach. So there, what I suggest generally for partially stochastic approach would be is to make help of hidden Markov model. So hidden Markov model is a partial stochastic model. In that, you can try to see a malware analysis. Recently, 2020 also, we got good papers on hidden Markov model with malware classification. Okay. Have I answered to you, ma'am? Kitna, ma'am? Have you got screen? 1 second. Okay. 1 second. I'll again repeat. See, your question was about how to go for malware analysis with time series based model. Now, only answer would be is like to understand the data and do some process model generation using time series aspect. So there you can make a note of this link, right? Time series data analysis with pandas. Pandas is a library which is built with Python. Right? Now, if you come down to your data, in your data, you need to provide some time component as a feature. Earlier, what I discussed, I didn't show you any time component. Give time component as a feature. That means you are recording the time. Now, if it is different timings, that is 9:1, 9:2, 9:3 like that, then it means that it is a different time. Or you can try to understand that packets are getting transmitted within a time period itself. That means at 9:3, it actually means that it is 60 seconds, right, to go to 9:4. It actually means that it is 60 into 60 milliseconds to go to the next time. That means 600. Right? But within a second, there may be n number of packets going from the node, right? So you can actually record the data with respect to time, understand it as a time series based model. There you will have to look at what sort of a trend you want to predict. There you can look at moving average based algorithms. This is second point which I told. Third point, what I was trying to insist is, if you're going for such sort of time series based models, you will have to take support of stochastic algorithms. So partially stochastic algorithms, you can actually use hidden Markov model. So there I suggested if you go and search, you'll get hidden Markov model for malware analysis. So HMM, because it's a state-based model, so you can formulate it as a state-based model and you can work on it. Or you can actually understand it as a packet log, right? So it's actually a complete sequence. So there you can use algorithms like LSTM. Because deep learning architectures, I think people know that it is a stochastic based approach, right? You can use an LSTM architecture also to solve such problem of malware analysis. Okay. Uh, have you have you got the clarity, ma'am? Kirtana, ma'am? Hello.
Thank you, sir. I have one more question.
Please, ma'am, please.
Sir, when we are collecting data
Correct.
and how to validate our data set, um,
Mm.
how to validate our data set? Is there any like a benchmark data set? Or for example, if we take KDD data set and KDD data set don't have the recent attack. So if we are capturing the recent attacks like DOS attack,
Mm.
how to validate our data set? What are the steps we need to follow? How that our data set is perfect?
Okay. See. Okay. I'll understand your question. Your question is like, I have made a data set. I'm proceeding with my research or project, but I still have a doubt whether my data set is correct. Is it
Yes,
right?
yes,
Right.
sir.
The answer to that is, what I know from my experience would be is to understand what type of model that you're looking at, whether it is basically a network model or you're looking at something from IoT like that. If you're looking at IoT botnet dataset is a good way of doing it. Or otherwise, what people do is people actually set up a honeypot. You can also set up a honeypot. So you can assume that you have 3 to 4 computers. You can set up a honeypot, capture the log, and understand the type of attacks. Okay, this is one way people do, right? Other way is like, if you're going to the standard data sets like KDD, okay, and if you're looking at KDD data set for 2020, right, for example, you would actually get data set on KDD data set which is actually talking about attacks also, which is improved. What you would say is, we are actually trying to access the NFL KDD dataset, which is actually in 1999, right?
Yes,
But
yes,
that's
yes.
got improved by most of the papers. Most of the papers have improved the dataset, and they call it as improved KDD like that. So you can
Okay,
request such people, get the dataset, and you can try using it in your research. You can see here, no, KDD
okay,
2020 paper, right?
okay,
That's the only way, ma'am. Either you should
okay.
set up a honeypot or you should go for KDD. As you said, the 1999 will not have the
Yes,
latest attacks. So they request people who have built their network and got the data set and use it and acknowledge them in the paper.
okay. Sir, I
Okay.
have one more question, sir.
Yes,
Sir,
ma'am.
you just told that we have to add that timing. But
Mm,
is there any software automatically with the data and the time combinedly I can capture, sir?
Ma'am, that you can capture with Wireshark, ma'am. Wireshark will capture all the data logs with time only. Because
Okay,
whenever there's a request no going, it'll actually say send time, receive time. Right? Okay.
okay,
So there'll be a difference of time also. So whatever is a sent time, you can send time, you can record it as a time for your transmission of request.
okay.
But again,
Sir,
you have to go back to some network theory because for every say packet being sent, it might not get an acknowledgement there itself. You might get an acknowledgement at somewhere after 5 to 6 transmissions, right?
okay,
So you'll have to write a code, filter the packets, and then assume that there is one transmission at 901, but the transmission got completed as 93 like that.
okay. Sir, I have one more question, sir.
Please,
Sir,
please.
how to extract that flow level packets, flow level details, networking details, like instead of I don't want the packet payload and all, I want the flow details. Is there Wireshark will provide, so?
Yeah, for Vaishak, you can extract the flow level. Flow level in the sense, can you be very clear, ma'am? Actually,
Um,
what you want
uh,
to know?
like if it is SDN thing, I want to capture the data level and control level data, sir.
Okay, SDN means software defined network you're going
Yes,
for.
sir.
Ma'am, actually, what I suggest is, I don't know, you are looking from your research perspective or you're looking from,
Yes, sir. Yes,
um,
sir. Research perspective.
okay. So actually, as a researcher, what I generally suggest to people is you'll have to stick on to any one specific type of network, right? SDN is on the other side of network transmission, right? And if you're going for conventional networks, then that is on general type of transmissions.
Okay.
So closely related to this, if you're talking about the flow network, I usually suggest this paper. You can see this
Okay.
paper now, man. Flow and packet level model for internet, right?
Okay.
Ramji Vengaman and Balaji Pakkar, right, from
Okay.
Stanford University. If you look at this paper, they would actually talk about how are they measuring the flows. I think this is what
Okay.
you're trying to speak about, right? Your packet
Yes, sir.
level and flow level model,
Yes, sir.
right? And
Yes,
they
sir.
would say the simulation parameters that they have used.
Yes. Yes, sir.
And then they
Exactly.
would try to come back with the conclusions and results.
Okay.
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 So ideally, if you're going for flow level and all, then you have to simulate your network. I think there is something called as Omnet is there, right? Omnet
Yes,
is
sir.
also there for
Yes.
simulating flow level network. You can use
Yes.
Omnet also, ma'am. Actually.
We are using
But
MiniNet and STNet, sir.
okay, ma'am. Which college, ma'am?
Mahe, sir. Manipal.
Manipal.
Manipal. Yes, sir.
Okay, very nice, very nice. That's what, ma'am. Actually, as a research, you whichever software is giving you the support, you try to use that software. Sometimes the proprietary softwares like Omnet and all will not give you more flexibility to modify the code. Correct.
Oh,
So
yes.
there and all, if you feel that it is getting difficult, you take the logs alone, analyze the logs in your Python library or any other third party program.
Okay. Okay.
Okay.
Thank you very much, sir.
Yeah.
Because I'm having a confusion saying that because data set, when we are collecting data set, how to validate? Later, they may ask, is anybody approved that particular data set? So, how to answer that particular question? So, I was little bit worried about that, sir.
Now you have got some clarity, no, no, ma'am. You would have got some
Yes,
clarity.
sir.
Yes. So
Yeah.
usually, actually, I have two PhD scholars working on behavioral security in large networks, right? So we are trying deep learning models as a solution. We are actually trying to work on web phishing attacks on the network,
Okay.
right? What I say to my team of people, what I say to my researcher is, I say to my researchers saying that, see, you build a network, right? Your network log will come like this. Fine, right?
Yes, sir.
If you're not able to build a network where your network log is not generated, that means I have not set up any network, right, ma'am? So there,
Yes.
what I suggest to people is like, you just go and see what is a similar data set that is there. right?
Okay.
Let's take somebody has featured a data set. Go and see the data set and download the logs, right? Naturally, they will actually give us the logs now, ma'am. See here, the database is available. I think you can see here, right? The data set is available. Just download the data set. Once you download it, it will come as data set like this.
Okay.
Right, ma'am? It'll come as data set like this, right? Now you understand what the person has said.
Okay.
Okay. Now from that description, what I say to people is you would try to get some conclusion saying how each one of the features are varying. For example, this is a time varying feature. Am I right, ma'am? Yeah.
Yes, sir.
And these are all basically IP address values, which will be meaningful IP addresses. And these are all numbers. Let's take you say that the minimum network length is 12 and the maximum network length is 1200. Okay. And each one of them are actually values increasing in terms of 8. I'm just giving a constraint. Okay, let's take, I say this is 20, this is 12, and this is 20, right? Our understanding is each one of them are basically in terms of weight. Am I right? So
Yes.
you can write your own library in Python, that's a own program in Python, which will actually simulate the values for the features given the constraints for the features. Are we right?
Okay.
That means you have not created any data set. You have looked at the data set, understood the data set, but now you have a code saying that for every feature, what is a constraint, it will generate a data set. Hope
Okay.
I'm getting you. Right?
Yes, yes.
There you can actually say to somebody that, see, I very well understood this data set, but I'm not able to create one like that. So I wrote a Python library to generate the data, but my data set is very well valid because it maintains the same constraints of the original data set.
Okay.
So if you say 1,000, give 1,000 records.
Okay.
Right, ma'am? If you say 10,000, it'll give you 10,000 records, but all the constraints will match.
Okay. They
Hope
won't
I'm clear.
oppose, sir.
No. Nobody will oppose. Nobody will oppose as much I know from research. Reason is your data set carries the same ethics and
Yes.
it's actually a simulated data set.
Okay. Okay.
Correct. It's
Yes.
a simulated data set. It enjoys the constraints of what you saw, what you have in your real-time data set.
Okay. Okay. Thank you
Okay,
very
ma'am.
much, sir. Thank you very much.
Yeah. Thank you. Thanks for questions. I think it would have helped some other people also. Any other questions before we move on to the coding part, participants?
Hello, sir. Good morning. Apurva here.
Yeah, ma'am. Yeah, ma'am. Please.
Sir, with respect to this, you had mentioned that you were working on web-based phishing attacks.
Yeah. Correct, ma'am.
Sir,
We
like
have
what
started
data?
working. We have started working.
Yes, sir. So, what data set are you mainly targeting on? So, what kind of data set?
Okay, I'll just show you, ma'am. One
Yes,
second.
sir.
I'll show you.
Yes.
Once again, I'm sharing you the screen.
Yeah, sure, sir.
Okay. So we are now started seeing with Kaggle data set as a benchmark because Kaggle releases most of the data set. Unfortunately, we have a data set from Kaggle also for phishing websites. You can see here, no, ma'am. And this is a benchmark data set that we have started with. And we are referring to one more code repository shared by this person, Rubric, right? So he also has released a phishing data sets detection. I think you can see here, right? Website instances with legitimate and a phishing category, right? And this is a phishing website dataset which I was showing you from Kaggle. So you can also download the dataset, and this will have clear description for each of the features. As I have told you, for a feature 1, we'll say what is the meaning. Feature 2, what is the meaning, right? Everything will be available. Have I answered you, ma'am?
Yes, sir. Yes, sir. Thank you, sir. Sir, could you please share this link, sir? That would
Yeah,
be really
I'll put right now in chat box. Please.
benchmark data sets.
Yeah, correct. as other madam was asking, right, you should always have a benchmark data set, only then people will believe in your work, right?
Correct,
And we
sir.
cannot say
Correct.
that we generated our own data set, nobody will believe immediately. So
So,
use
like,
any
if
one of
that's
the benchmark data.
yes, sir. So,
Yes,
like,
please.
if that's the case, like, if we have a benchmark data set, that is fine, sir. If we do not have a benchmark data set and we actually create our own data set, so how can we defend at that time, sir?
That case, what I told you, no, ma'am, earlier I told you, right? You make your data set and your data set is something like this, right? But you can comment to everybody saying that I have simulated a data set. The simulated data set is having patterns. Characteristic of the columns is your choice. For example, if I say I have got values as network length as 12 to 100, 200, that is the minimum and maximum limit of your original network length, right? And in your training data that you got from the internet also, they had values as 12 to 1200. Are you right? Then next is in each varying distributions also you can give your comments. You can say that for 2 seconds, right, the varying network length in the original data set was between 10 to 20. In mine also, I'm getting only 10 to 20 as a simulated value. So there people will appreciate the understanding of yours to your simulated data set.
Okay,
Hello.
okay. So, as a yes, sir, got it, sir. So, as a comparison, we will have to show it and then we will have to defend
Yes.
it.
Yes.
Right.
Actually,
Okay.
if you go to any network simulators, no, ma'am, if you take NS2 or any other simulators, they would also generate a data set like this, but they would actually come up with some varying patterns. They will say, would specify the queue type, specify the type of distribution, whether it is Poisson distribution like that. And based on that, they will generate the data, right?
Right. Yes,
There
sir.
they are building a network traffic model, right?
Okay.
We are not building any network traffic model. We are just building a network data set which resembles an existing data set.
Okay. Okay. Got it, sir. Got it. Thank you, sir. Thank you so much.
Yeah, yes, ma'am, yes. Any other questions from participants? Okay, fine. If there's no questions, then we will go on to the coding part of the session, right? So as I told you, my first part today will talk to you on machine learning with analyzing of malware data set. I think all of you have installed the software, right? Can you give me an acknowledgement in the chat box, please? Hello. Any acknowledgement in the chat box? I think organizers have already shared you that you should have your softwares installed. Anybody has installed Anaconda? Please say either yes, no, we are all teachers. Something should come from anyone of the side. Okay. Yes, sir. Yes, sir. Okay, fine. I'm getting some good yes, so I feel that everybody is installed, right? Okay, right. So what I have shared in the first requirement is I've told the people that we need to install some software. So the software should be minimum. What you should have installed should have be Anaconda, right? Because whatever code that you are trying to run will run in this Anaconda framework. So when you are installing Anaconda, then automatically you will have your third-party libraries mostly installed. What I'm trying to conclude is most of the third-party libraries will be installed when you are installing Anaconda, right? Okay. So once you open your Anaconda prompt, I think each one of you would have got Anaconda right now. If you open your Anaconda prompt, you'll get your prompt like this. And there are two editors that will come with you. One is your Spider, right? And the next editor that would get installed is something called as Jupyter. Right? One is Spider and next is Jupyter. Okay. So um, members, have you got your code and data set in your group mail? Hello. Please acknowledge. Members, have you got your code and data set in your group mail? Please say yes, no. Participants, I'm waiting. Hello. Yes.
Participants,
Yeah, okay. Ma'am, I think
Yeah.
participants would have got the code and data set, no, ma'am,
Yeah,
which
now we shared in the chat, sir.
you had shared in chat.
Yeah,
Okay.
No,
yeah,
but
yeah.
we have not received an email. Email is not received.
Okay, I think has it come in chat, sir? I think
It is shared in the chat box.
chat.
Just now, sir.
Okay, ma'am. Okay, no problem.
Participants,
Please,
please you can use that.
please take the code and data set. Please take 2 minutes. Okay, participants, have you downloaded? Please download the data set, download the code.
You can see in the chat, please download.
Sir, not able to download the data set and code, sir.
Hello.
Sir, not able to download the contents, sir.
Why, ma'am, actually?
I don't know, sir.
Who is
We
it?
are paid.
Participant or?
Yes, sir. We are not able to download, sir. Yes, sir. Participants.
Okay. Ma'am, actually the organizer, I think, can you give a solution, ma'am, please?
Sir, we are sending in mail now.
Okay, ma'am.
Yeah. Send in mail. Okay. Please see.
Thank you.
Send in mail.
So as a first step, you will be getting the code for K-means and KNN. As a second step, you will be getting the code on ADA Boost from the organizer side. So we will try two algorithms for today. One is K-means and KNN, and next is ADA Boost.
Participants is also shared in the WhatsApp group. Hope you are able to access it now. Okay. Yes.
Organizing team, I have shared ADA Boost also now to mail. We can share the same also to the participants.
Okay, sir.
So they'll have two codes for today. One is K-means and KNN with malware. Next is ADA Boost classified.
Okay, sir.
Have people downloaded? Can you acknowledge so that we can start with the session part? Hope you got your Anaconda environment is also ready. It's okay. Can you say an yes in the chat box? Yes, Apurva, comment. Okay, participants. We will continue. See, actually, the discussion for now would be on analyzing the two algorithms for malware analysis, right? So algorithms in the sense K means KNN, and second one which we'll be looking for analysis will be ADA Boost classifier, right? Please mail the document. Ma'am, Sagarkya, okay, no, analysis. As I told you, when you have a data and we are interested in classifying the data, the question is like how to give a class label. There you can use k-means. So given a test data, now I challenge is how to find the class label here. That is predict the class label. There you can use k-means class label. Fine. Now our next question somebody would ask is when you are looking at k-means, right? How does your k-means algorithm work? Right? That's a fundamental question for everybody. How does your k-means algorithm work? Let's take your data is like this. Okay, let's take your data to be like this. F1, F2, F3, and this is class label, right? Now I have some values for this data. Let me take the values. I have some values for the data. So my values are like this. So these are my features. Okay. These are my features. Right, ma'am. Please, one of you acknowledge. Am I audible? Participants, organizers, can you acknowledge it, please? Yeah.
Screen is not visible, sir. Your slides are not visible.
No, I'm not sharing any slide. I'm showing from the Excel sheet. Are you able to see the Excel sheet?
Yes, sir, we can see.
Yeah.
Okay, right.
Yes,
Now,
sir.
yeah, thank you. Given some features like this, our question is to find out the class. Let's see how a k-means algorithm does. All right. What is a k-means algorithm does is, a k-means algorithm will try to take the distance of the data, right, and try to associate it to frequent class, right. Let's see how does it do here. For example, if it understands the problem to be as a binary class problem in the sense the class label is either 0 or 1. Class label is either 0 or 1. It's a binary class problem, right? So let's take here class labels are assumed to be 0 and 1 like that, right? Now let's take you get a data. I think somebody has to mute the audio, please. Let's take you get a class data like this. Yeah, you get a class data like this with this values 12, 23, and 10. So what does it do is it finds the closest distance to which it falls, right? For example, it will try to compare this record, right, with all these records here. For example, 12, 23, 10 is a test data for which you want to find a class. It compares it with this, right? It compares it with an instance from class label 1, right? In comparing with class label 0, its distance measure, let's take it as 12. In comparing with class label 1, its distance measure is 6. So what does it conclude is, it concludes saying that this given test data falls to a class label as 1 here, right? So that's how a k-means algorithm works. So here, how do you fix the number of clusters? Normally it can be 2 classes, 3 classes, 4 classes like that, right? Clusters. Okay. So let's look at this here. If you look at the internet and see this algorithm called as elbow method, go to internet and type elbow method k-means, right? This will actually speak about an algorithm. Your elbow method k-means, yeah, you can see here, right? So elbow method is a popular method for fixing the number of clusters, because if you are given a data set like this, most of the people will get a doubt, right? You don't know what is a class label at all. There is no benchmark data for this. So how do you fix it? It can be either 2, 3 like that. So fixing the number of classes is left to this method called as elbow method. Please make a note, elbow method. Okay. Then next information for everybody is, if you had TCP, ICMP like that. But if you look at a data set like this, it is not having any categorical data. Given the data, like, you cannot find the difference. So there you will have to make use of this approach, which is called as one-hot encoding. This is again one code. This
Sir, your
algorithm
voice.
will try to can it, hello.
Hello, sir.
Yeah. So if you go and type one not encoder, you'll get an algorithm on one not encoding as you see here, right? The purpose of this algorithm is to convert a categorical into a numerical. So if you look at this here, this is a categorical data like this. TCP, ICMP, IP is all categorical data. This will be converted to a numerical data. Fine. Now, the next thing that we have to start discussing is implementing a model which will actually take through a malware data set and classify the data set. For that, I have shared you a code. I have shared you a data set also. So let me take the code and data set which I have shared to you. Now, if you look at this here, this will actually show you first a malware data set, right? This will actually show you a malware data set. This is one of the malware that we have taken for our example discussion here. So the idea is to classify it as a binary class. Again, I'm repeating, the idea is to classify it as a binary class. Hope you can see the data set, right? This data set is built from IoT botnet data set. Are you able to hear, please? Hello?
Yes, sir.
Participants? Yeah, this is built from IoT botnet dataset, but certain features we have not considered. Please understand, if you see the number of columns, this will not be equal to the number of columns that is there in the IoT botnet dataset. Whenever you want to classify an attack, right, you need to look at the features which are important for your problem. So we have took the dataset, we have removed some columns, right, because it is not required to the type of attack classification. Now, if you look at this here, if you ask what is dimension, dimension corresponds to number of columns in this data. Number of columns is your number of features. So if somebody is asking you what is the dimension of your data set, right, you will have to say it corresponds to the number of columns, right? Now, what is dimensionality reduction? People will ask you in machine learning, what is dimensionality reduction? If you have expressed your data with n columns is till here. If you can reduce your data to less than n columns, for example, you don't have this column at all. So what has happened now? The original number of columns is reduced by certain number of columns, right? There, what people say is we have achieved something called as dimensionality reduction. So one possibility is to actually remove some features which are not required and say that you have achieved dimensionality reduction. Other possibility is if you go to the internet and type this algorithm, the algorithm name is principal component analysis. If you go and type principal component analysis, you will get an algorithm through which you can reduce your number of features. So why are we doing this? It is usually a common understanding that when the number of features get reduced, the performance of the system gets improved, right? Because instead of working with n features, you are working with less than n features. N corresponds to the number of features in the data set. Fine. So this is an example of a malware data set here. Now, if you come down here to this, what is being shared to you, you will have another data set which is called as analysis, which is called as analysis. Here, we have set down the data set to this, right? Okay. Now, if you can look at this here, certain columns will be categorical. Right now, our requirement is we need to classify this data, right?
Sorry, your voice is breaking in between.
And we need to do a prediction. Thought processes given a data set. Hello, am I
Excuse me.
audible?
Yeah, now it is audible, sir.
Okay, right.
In between, it
Sorry,
was
I think
breaking
I'm facing
actually.
some network problem.
Okay.
Yeah, please. Yeah. Now, given a data set like this, our requirement is to classify the data set with respect to class label because we don't know what is a class label. Fine. So their usual approach is if there are n records, training you can take 20%, and for testing you can take 30%. Right? For training you can take 70%, and for testing you can take 30%. Just give me a second. Okay, given n records, you can take 70% of the records in training, and 30% of the records you can take for testing. So it is like if you have 100 records like this, you can take 70 records for training, 30 records for testing. Fine. Now let's come down to the code part. Now this is a code that is shared to each one of you. If you can go through the code, this is the code that is shared to each one of you, k-means and knn, right? If you walk through the code, right, the first lines of the code are corresponding to the libraries. If you want to work with your machine learning, you need some libraries to be installed. So one library will be NumPy, the next is Pandas, then Matplotlib is for visualization, right? And next is CSV is, since we are trying to handle an Excel sheet, then you will be interested in some plots. So SCI kit plot, fine. Then if you are looking at your algorithms part, we want to use KNN with k-means. So here in this code, here we have used k-means. Here if you come down, here we have used KNN. Right? That's your k nearest neighbor. Then we are interested in calculating precision recall. So the metrics class will be used under sklearn. So sklearn.metrics precision recall, right? We want to show the confusion matrix. So confusion matrix also can be presented. Then if you come down to the lower part of the code, this is a part where we are trying to access a file. So you have your CSV file, right? So file name is analysis. So analysis.csv. Then the next step is we want to do an encoding. Reason is, as I told you, some columns may be having categorical value. So the procedure is just say pre-processing.label encoder. This will convert your categorical data to a numerical data. The next line is we have n columns, right? So we want to take all the columns. So column 1, column 2, column 3 till n columns. For each column, what we want to do is we want to do an encoding if required. You can see here. So that's done by using the transform operation. Then next what we are doing is we are calling k-means. K-means as such is inbuilt as part of the sklearn. You can see here sklearn will automatically have k-means. So we have imported that in the code sklearn.cluster import k-means. Fine. So then what we are trying to do is we are trying to run through a k-means classifier. Then we are trying to run through a KNN. We are trying to run through the KNN here. Here the number of clusters we are fixing it as 3. Okay, number of clusters we are fixing it as 3. So you will find class labels coming as 0, 1, 2. Right? You will find class labels coming as 0, 1, 2. Right? So clusters is fixed to be 3. Then we are running through a KNN. Fine. Then finally we are printing what is the total number of records for training, total number of records for testing. As I told you, 70% records you can take it for training, 30% records you can take it for testing. Then what we are printing is a confusion matrix. Fine. Then rest of the things is for plotting the values of the confusion matrix. Follow on to that, we are trying to print the performance metrics. The performance metrics are printed like this. For each class, what is a precision recall, F1 score and support, right? For each class, what is a precision recall, F1 score and support, right? Now, if you come to the output, you can come down to the output and see. For each record, we are trying to print what is a class label. Records we have got in the analysis file is 16. 70% is taken for training, that is 42. 30% is taken for testing, that is 18, right? So this is your predicted output. Predicted output in the sense what we have from your final output is your predicted output. 1 second. Okay. Now when you run through the results, each one of you would get like this. 70% will be the training data, 30% is testing. This is your predicted output, this is your actual output. Okay. So next, what we are trying to show is a performance part. Performance part here in the sense we are showing the individual classes. Here we are trying to take it as a binary class label. You can see here 0 and 1. So class 0, class 1. What are the values for precision, recall, F1 score and support? Here we are achieving 100% accuracy. It means that, as I showed you from the beginning of the session, each class label that is predicted using k-means has got the same class label if you are running with k-means also for the test data. So what we are getting as such for the example that we have run is like this. Okay. So each class label is correctly getting predicted for the individual instances. So our accuracy that we are getting here is 100. But generally, as we start improving the data, you start seeing more challenges in the data. All these accuracy values will change. So are you all able to run the code? Can you put an acknowledgement in the chat box? Participants? Or anyone discuss that also with the error? Hello, am I audible? Yes, Kirtana ma'am. Okay. Everybody's get somewhat okay. Anybody's getting error? Anybody is getting error? Participants, please acknowledge.
Participants, you can unmute and tell.
If you're getting error, please say what error you are getting. Or if you're getting output, please say you're getting output. How many of you are getting error? Please put in the chat box. At least that can come up. Request the participants to put error status if you're getting in the chat box. One problem people might face, I'm saying it as a general problem, would be it's like, sir, I'm running, but the code is showing, let's take NumPy is missing, right? Or one library is missing. Let's take it says that sklearn is missing. I'm running the code. It is saying that sklearn is missing, right? In that case, you'll have to go to your command prompt. Yesterday, I put in the document also. You'll have to go to your terminal, right, of your Anaconda. Let's take this as your terminal of Anaconda. There you have to go and type pip install sklearn. Okay. Pip install sklearn. Now what will happen is it will try connecting to the internet. It will try installing the library. So wherever you open the code in Spider and it's showing you some error saying that one library is missing, unrecognized keyword, what you do is you try installing by going to the command prompt and say that pip install that particular keyword. So now my system has already installed sklearn, so it is not showing me any error, right? It says that successfully built, requirement is already satisfied. So this is one error people might get. When you run the code, you're not getting the output, but it shows you an error saying that something is missing. So something is missing means you just go to your Anaconda prompt, right? And in your Anaconda prompt, please put pip install that particular library. If you don't get the syntax, don't worry. As I have put up in the browser link yesterday with the document, you can actually go to the internet and say installing, right, sklearn. Installing sklearn, link from your sklearn website. Through that, you can actually go and see what is a command for
Sir?
installing sklearn. Yes, madam.
Yeah, there is an error. Put in the chat box, sir.
1 second, ma'am. I'll check the error.
Yeah.
Module not found, no module named SKI kit plot. That's what, ma'am, you have to say pip install SCI kit plot. I'll show you here. So for this error, please go to your Anaconda prompt, right? You type pip install. Okay. So now it will get connected to the internet. It will install. Okay. For me, it's already done. So it will remain the same. Any other error, please? Any other error? So any library that you get as an error, don't worry, just go to internet, search for the installation procedure, or directly you can try pip install that library name. It will get connected to the internet and it will try installing. Right. Okay, anybody has executed the code and getting the output, please acknowledge in the chat box. Everybody is getting the output in the sense like what I'm showing you here. Okay, you can try running the same thing in your command prompt also. I'll show you that also. So now I'm saving it in my local directory, right? If you can see here, my terminal is showing me C drive users sendel, right? So I go here and I go to C drive, I go to users, right? I go here to sendel and I try to save my file. So when you save your file, please save it with py extension, right? Okay, so I'm just saved my file. Now what I can do is I can try running from here also. So I see k-means and knn file, right? So I can say Python k-means and knn. So I'll just save it again. Save as. I'll go to C drive users. Saving my file. You can go here. You can run from your prompt. You can say Python. This is the other way of running the code, but sometimes the visualization plots might not come properly. Like in the next session, I'll be taking you through on precision recall curves and all. So in case you're getting errors like that, then that case you can do it from here. What is the error I'm getting is analysis.csv doesn't exist. Reason is in the coding part, I've just given not the path, I've just given analysis.csv file. So what I'll do right now is I'll go here, I'll take the CSV file, right? I'll take the CSV file and I'll copy it to the working directory where I'm trying to run the code. So C drive users send. So there I'll go and copy this file. Now the file is copied. Now I can come back to my prompt and I can try running my program. Now it will work because now I kept my CSV file also in where I got my program. The confusion matrix, this is what I was saying you. Spider as such will not show you all the visualizations. So the confusion matrix is a very good performance measure. Reason is to show you the possible classes, class 0, class 1. So it's a binary class problem. So if you look at this here, it is an ideal classification. That means it is correctly classified. So along the diagonal, you will get values. But what is an example of a misclassification is if you get values above the diagonal or below the diagonal, it is a misclassification problem, right? So here we are not getting any misclassification. So in any machine learning models or deep learning models, people suggest you to demonstrate with a confusion matrix like this. Okay, so this other way of running your program. Any other errors people are getting? Please put up in your chat box. Any other errors? What is the error you're getting, sir? Escape, kit plot. After that, what are you getting? Maybe sometimes what happens is your installation would have happened correctly, but you need to restart. That means restart in the sense close once Anaconda prompt, right, and spider, and restart again and run. Or as I told you, you take the program, put it in your working directory. Your working directory, let's take the C drive users, some working directory. There you copy the program, there you copy the CSV file and try running saying Python space, right? There it might work also. So that's my other suggestion to the people. Fine. So keep now next one that I would like to attend is Adaboost, right? Adaboost classifier. I think the team members have already shared you the document, right? Classify. The purpose of Adaboost classifier is to actually improve the misclassification. Here we will talk about something called as creating a learner, right? So you are giving some data. Now the data is assumed to be having instance values as xy, right? So you have m, so instances, so x1, y1 to xm, ym. So what we will try to do in the Adaboost classifier is we will try to create a hypothesis. The hypothesis is initially said to be a weak hypothesis. So the notation for hypothesis is h suffix t, right? So later what we will try to do is we will update this and we will try to get a strong classifier, right? We will not come into the mathematics part of it. Now the next one that I want you to see through is what does an Adaboost classifier does, right? For this the code is already shared to you all. So we will come down to execution of the code. So I'll try opening the file. So desktop, Adaboost classifier, right? So for this, a dataset is used. Okay, the dataset name is called as dataset.model.csv, as you can see here. Right, the code will resemble to what you saw from k-means. Only thing you will find that in the code we would have added Adaboost classifier. Rest of the things will remain the same, right? So in this again, what we are doing is we are taking the dataset. The dataset that we are using is Adaboost dataset. Here example, here is dataset model. If you open this dataset, this will have features as like what you saw, no? This will have values, right? Okay. So there are 32 features. So we are not worried about the column names. So we just give the feature numbers as ATT1. Okay. Now what we want to do is we want first to do k-means, right? And testing part, it will do Adaboost classifier, right? Okay. So then it will actually run through as what we told. We will try to show the performance with the Adaboost classifier. If you run with Adaboost in this model, you can see here the performance is not the best. You can see here the performance we are getting is only at an accuracy of 0.77, right? 0.77 is accuracy. But with k-means what we got is accuracy is 100%. So in conclusion, we can actually say that Adaboost is not doing better compared to the k-means classifier, right? This is how we compare one classifier with the other classifier here. Now, if you come down to where we have lost in the classification part, right? I'll show you here. So we will save the same file, right, in C drive user. So let's take the file from here. So we take the code part and the Excel sheet. We'll go to C drive as we did for your k-means. We are doing users. So this is my working directory. I'm just going here and pasting. Now I pasted my code. I pasted my data set also, right? So I can now go to the command prompt. Okay, so here we will try running Python code. It's your database classifier. So we'll go and take the file. So this is your file name. So let's see the properties. So it is AdaBoost. So AdaBoost.py. Okay, so let's go here. Python AdaBoost.py. Now, when you try running the code, again, what is the error that we are getting is, yes, file not found, dataset model.csv. So we have, okay, we have to copy the text Excel sheet also. So we'll try copying that file. So desktop, Balaji College, yeah. So AdaBoost is their Excel sheet, right? So we'll take the Excel sheet. We will come down to the working directory. It's yours. Dataset model. It is there right now. That's dataset model. Okay. Now let's come to our output. So file not found. Okay. One second. One second. I'll correct this error. Just give me a minute. So the error is actually with the file path. So I'm changing the file path. That's what I'm doing. So I will go and give the relative file path where I've saved my file. Now it's done. We can see the output. Once again, I'm sharing my screen. Okay, so I'm sharing my screen. So, okay, now you can see the output, right? So if you can see here we have given classifications. Now you can see misclassifications above the diagonals, right? Above the diagonal we got some misclassification. Below the diagonal we got some misclassification. Whole challenge is when the misclassifications increases, automatically the performance of the model also increases. So your accuracy also will come down. So here with this data set, the accuracy is come down to 83%. Okay. So this are the two things which I wanted you to see today, so that you get a feel of running through machine learning algorithm with malware analysis. Any questions from your end? So my next session will take you through on looking at deep learning algorithms. So there I'm trying to look at an LSTM for malware analysis. Okay. Any clarifications from your end, participants? Any doubts? People who are left with errors in the working environment, request you to make the environment ready, and it will be helping you when you have the interaction with my next session, because the next session again will be taking through on Python with the TensorFlow, right, and Keras. Any clarifications from your end, participants? There's a big silence. Please unmute your audio and respond, please. Any clarifications from your end? No, it's clear. Okay, Apurva ma'am, fine. So yeah, I think your organizer will arrange you to have the video session of it, whatever we have taken today. This is to Shetty Akshaya ma'am, right? Okay. So I will leave you my mail ID also. Please request everybody to get the working environment done. In case you don't get the working environment done, that means you are still getting errors. Please send me the screenshot of the error that you're getting. I'll give you the solution for the error. I put my personal Gmail ID also in the chat box, right? So it will be helping you to send back the errors, right? Now going forward, what we will do in the next session when we meet is we will take the same malware data set. We will start looking at how deep learning can be applied. Today we have seen one from k-means KNN and boosting classifier. The same thing we look at from a deep learning perspective and see how classification and prediction can happen using deep learning approaches with malware, right? And if you have a doubt about what is malware signature, it is as like what I told you. If you open any Excel sheet of a malware data set, right, it's got nearly lot of features, right? So these features are corresponding to malware signatures. So if you want to categorize and say it is a type of malware, you'll have to categorize a malware from your attributes, that's your features of your data, right? So look at your features. Your features will actually try to give you conclusion about the signature of the malware, right? So the features are like what I was showing you earlier. This is your data set, a complete set of row, right, with all the features, an example of a malware signature, right? So that's it for today from my side. In conclusion, I've taught you on malware, categories of malware. I walked through on the code of ML algorithms, that's k-means and KNN and AdaBoost classifier, right? So in coincidence, actually, I have a funded project from IBM where we closely investigate malware analysis on real-time network. So what we have been trying to understand, we have shared to you. Okay. So thank you from my side. If there's any questions, I'll take it up.
Participants, if you have any queries, you can put in the chat. If you have any queries, you can ask.
Okay, I'm not getting any questions. I think the information has reached to you all today. Please request everybody to get the working environment done if the error is still there. And when we join back in the next session, we will start with deep learning architectures for same malware dataset. Okay. So thank you from my side for patiently listening to my session. And thanks to the organizing team of Balaji College, Gopalan College, please.
Sir, thank you so much, sir. It was very informative. Actually, it would be very helpful for the researchers also, I guess. So, expecting more sessions from you, sir, in the future.
Yeah, sure, sure.
Yeah.
I'll do my part always.
Yeah.
And thank you. Be safe.
Thank,
Thank you all. Thank you so
thank
much.
you so much, sir.
Thank you.
Thank you so much, participants. Next section will be at 2 o'clock. So, please join on time. Yeah.
Thank you.